Today's lesson is on comparing rates. For our first example, we're comparing proportional relationships. The distance, y, in meters, traveled by a 4-person ski lift in x seconds is represented by the equation y equals 2 5/10 x. The graph shows the distance traveled by a 2-person ski lift. So for A, which ski lift is faster? So the graph that we have shows the distance for a 2-person ski lift. For a 4-person ski lift, it says that the equation is y equals 2 5/10 x. So for a 4-person lift, the equation is written in slope-intercept form. Y equals 2 5/10 x. So the 4-person lift travels 2 5/10 meters per second. Now for the 2-person lift, we should look at our graph. We want to find our slope, so we would do our rise over run. So we have 2 points here. You can see that our run would be 4, our rise would be 8. So our slope would be 8 over 4, and 8 divided by 4 equals 2. So the 2-person lift travels 2 meters per second, because this equation would be y equals 2x. So the 4-person lift is faster than the 2-person lift. We're going to continue with example 1. We have B. Graph the equation that represents the 4-person lift in the same coordinate plane as the 2-person lift. Compare the steepness of the graphs. What does this mean in the context of the problem? So for our 2-person lift, we had our slope of 2. We had y equals 2x. So if we start down here at 0, we would go up 2 and over 1. Up 2 over 1, up 2 over 1, and you can see that the red line is the graph y equals 2x. The 4-person lift was y equals 2 5/10 x. So we would go up 2 5/10 and over 1, and then 2 5/10 again would be at 5 and then over 1. And 2 5/10 again would be 7 5/10 and then over 1. So you can see the 4-person lift is the blue line. So the graph that represents the 4-person lift is steeper than the graph that represents the 2-person lift. So the 4-person lift is faster. For our second example, we're comparing functions. The earnings y in dollars of a nighttime employee working X hours is represented by the function y equals 7 5/10 x plus 30. The table shows the earnings of a daytime employee. So you can see for our time in hours, we're going to go up by 1 each time. 1 to 2 is plus 1, 2 to 3 is plus 1, and 3 to 4 is plus 1. And you can see our earning in dollars, we're going to go up by $12.50 each time. So we have $12.50 to $25. Go up $12.50 again, and we get $37.50. And then go up by $12.50 again, and we're at $50. So which employee has a higher hourly wage? The nighttime employee had an equation of y equals 7 5/10 x plus 30. So the nighttime employee earns $7.50 per hour. And we're just looking at the higher hourly wage. The daytime employee would be our change in earnings over our change in time. So we're going to have $12.50 over 1 hour. So the daytime employee earns $12.50 per hour. So the daytime employee has a higher hourly wage. Now we're going to continue with example 2. We have letter B. Write a function that relates the daytime employee's earnings to the number of hours worked. Graph the functions that represent the earnings of the 2 employees in the same coordinate plane. Interpret the graphs. So we're going to use a verbal model to write a function that represents the earnings of the daytime employee. So our earnings equals the hourly wage times hours worked. So we're going to multiply our hourly wage times the number of hours worked So we have y equals 12 and 5/10 x. That is represented by the red line. Then the blue line was our nighttime employee, and that equation was y equals 7 and 5/10 x plus 30. So you can see that we're starting here on the y at 30 because that's our y-intercept. So the blue line is our nighttime employee. So the graph shows that the daytime employee has a higher hourly wage, but does not earn more money than the nighttime employee until the person has worked more than 6 hours. You can see here at 6 hours, they're both going to make the exact, the same amount. They're making the same amount, and then after 6 hours, it changes again. Don't forget to fill out your notes, and remember to watch the video again if needed.